Good morning and welcome. Today is September 16th, 2020. Please set up your notebook with this title, Graphing Absolute Value Functions, Vertical Transformations. F of x equals the absolute value of x plus d. Go ahead and write down today's objective as well. Today you will learn how to graph an absolute value function using vertical transformations in the form f of x equals the absolute value of x plus d. All right, and so as you can see, we have on the left just the basic parent function of the absolute value function, where the absolute value of all the inputs is equal to the outputs, right? So, we got the absolute value of 0 is 0, we got the absolute value of 1 is 1, 2 is 2, 3 is 3, and then on the negative we have absolute value of negative 1 is 1, negative 2 is 2, negative 3 is 3. So this is the absolute value parent function. And we're going to leave it on the graph so that we can compare it with the examples that we're going to be doing. And so the first example that we want to do is to graph f of x equals the absolute value of x plus 4. So this right here in the back would be our letter D. Okay, D shows up typically behind the absolute value. I suppose it'd be possible to write it in the front connected with addition or subtraction, but that would just not kind of be typical, so we tend to write it in the back. And so in this case, D is 4. And what this does is after the absolute value is taken, it adds 4 to all of the outputs. And so because we're adding 4 to all the outputs, that's going to cause the graph to go up by 4 units. So D equals 4 is going to cause a vertical shift up 4 units. All right, and so on the graph, basically then, instead of starting at 0, 0, okay, if we were to input a 0, if we were to say the absolute value of 0 plus 4, all right, if we input 0, our output would be 0 plus 4, which is 4. So instead of being 0, 0, like the parent function, the starting point is now 0, 4. So 0, 4 is right here. So notice the origin, or the vertex, has moved up 4 spaces. And that's going to be true for all of them. So just to show you, if I were to say 1, 1, all right, the typical point was input 1, output 1. If I input 1 into this new function, I would get 1 plus 4, which is 5. So if I input 1, it would output 5. So 1, 5 is right here. And hopefully you can tell that both of these points here have simply gone up by 4. And that's going to be true for every single point on the graph. And so to graph it, what I'm going to do is basically take the exact same shape, but I'm going to start at 0, 4 instead of starting at 0, 0. And this right here would be our transformed function. So notice nothing else is different. It's still the same shape. It hasn't moved to the left or the right. It hasn't been stretched or compressed or reflected. The only difference is a vertical shift up 4 units. And that's what we're looking at with the letter D.